All right, in lesson 4, module 2, we learn about a reflection. It's another type of rigid transformation in the plane. It's like translations in the fact that we're moving it, but we're actually reflecting it like what's in a mirror. So I'm going to just show you on GeoGebra again because it's really easy to see. If I would like to, let's see, let's do a point first. I'm going to make a point A, and let's make a line BC. And I want to create a reflection. So underneath there's something options. Let's just say a reflect about line. I'm going to select A to reflect, and I'm going to select the line as the point of reflection. And what happens is just like in a mirror, when we imagine that we folded the plane at the line. That line was where we were going to fold our paper. Wherever that touches would be that point A. So A goes to A prime. And furthermore, if we were to make a line between A and A prime, the distance from A, okay, see that point D where they intersect? The distance from A to D is equal to the distance from D to A prime. Because when we reflect, we're going to keep that distance apart the same. And no matter how we move those points, I want to move A. If I want to move A about that line, I move it closer or further away, guess what? They stay the same distance away from that line. So you can see that no matter where I move that, those are going to stay the same distance and the same angle of reflection. All right, let's try something else across line AC. Let's try a shape. So let me make a polygon. Okay, so I made a triangle, ADE. And I want to reflect ADE across BC. So what you can do is you go to reflect about line, gonna select the shape, gonna select the line, and it should reflect it. And you notice that when you turn your head, it looks like I took the paper, folded it in half, and made an exact copy. Okay, and again, if I had a line between E and E prime, and I had this point F, EF would be equal to FE. And another thing that I want to mention is that the shape that we're reflecting stays exactly the same. The measure of angle ADE is the same as the measure of angle A prime, D prime, and E prime. Angles stay the same. Lengths of sides stay the same. The length of DE is the same as the length of D prime, E prime. We're not changing the size. We're not changing the shape. Nothing changes except for the distance from that line. Think of it like looking in a mirror. Okay. So the important things to remember for this lesson is that a reflection is basically just another type of a transformation, another type of motion in the plane. A reflection occurs across lines. The line that you reflect across is called the line of reflection. Sometimes we call this line of reflection the axis of symmetry if we're talking about symmetrical figures. And if there's a point P joined by its reflection P prime, so let's say there's a point E joined by its reflection E prime, the line of reflection bisects the segment E prime. So that, like I said, EF is the same as FE. It bisects it, cuts it nice and evenly in half.